Alrighty. To solve this, this is a fractional power solving equation, but are you okay? This is also a radical. See that fraction right there, the denominator 3? This is a cube root problem. But I'm not going to make it a cube root. I'm going to leave it with a fractional power because it's a lot easier to deal with. To solve it, though, I first want to get this fractional power piece by itself. All right, so to get this by itself, I got to get that 2 off, and that 2 is connected by multiplication. So the opposite of multiplication is division. So the first step is just divide by 2. And I have now x plus 2 to the 2/3 equals negative 2. So that's my first step, is to get the fractional power by itself. Now we could change that to a radical, but it's easier to do other stuff. Meaning, I want to get rid of that fractional power, so what you're going to do is power both sides by the reciprocal. So the reciprocal of the power is 2/3. So the reciprocal would be 3/2. It's getting kind of tight on space, but you're going to 3/2 power both sides. And what happens when you do that is 2/3 times 3/2 is 1. So that simply leaves you with just x plus 2, which is very, very nice. All right. Then I have negative 2 to the 3/2 power. That you could look at, but I'm going to change this one to a radical. So when I have right here 3/2 power, let's change this back to a radical to see what this answer looks like. When I change that, hopefully you can see here that you'll end up with a negative 2 inside, correct? And since the denominator is a 2, doesn't that mean that's going to be the root? So do I need to put that 2 right there? No, because a 2 root is a square root, so I don't need to put it there. I could put a 2 there. I don't need to. But where's that 3 going to go? Inside and cube the negative 2. So we are going to cube this negative 2. So far, that's my answer. All right. Now, whenever you solve, don't you want to get x by itself? So how do you get rid of that plus 2? You subtract it off. So I'm just going to minus the 2 over. And I have x equals negative 2 plus the square root of what? Well, what's negative 2 cubed? Let's do that right now. Isn't that negative 8? All right. So negative 2 plus the square root of negative 8. Now, before we start breaking down the square root of negative 8, isn't this imaginary? And we're not going to deal with imaginaries dealing with square roots, because imaginaries create issues with square roots. We're going to deal just with real numbers. So is this a real number solution? No, it's imaginary. So we're going to say no solution because it's imaginary. So this is an imaginary solution. So it's no solution. Or no real solution. So we're going to call this a no solution because there's no real solutions to this. The only answer would be an imaginary answer, which is not going to deal with that. When we solve number 2 here, what I want to do before I start getting rid of any square roots by squaring, I want to get this square root isolated or by itself. So to get this square root right here by itself, I have to get rid of that 3. Since it's held on, since it's a positive 3 and it's held on by adding, I'm going to minus that 3 over. And I now have the square root of 2x plus 29 equaling x minus 3. Now, next step is I want to get rid of that square root. So could I now square both sides? Hopefully you see, yes, I could square both sides to get rid of my square root. But like you hopefully notice, there's something a little ugly about to happen. Do you notice I have an x minus 3 squared? So guess what we have? Foiling. Once you FOIL, you're going to have a quadratic. Once you have a quadratic, you got to solve by quadratic formula, complete the square, or factoring, or something. So this problem's starting to be kind of ugly. But it's doable. So let's solve this now. We got rid of our square root. We have no square roots. Let's start solving it, getting x squared, and you'll see. I'm going to FOIL over here. So I multiply those two, get x squared. Then I'm going to multiply that, and I get negative 6x. Kind of skipped a step there, but it would be negative 6x. Okay. And then negative 3 times a negative 3 is a positive 9. And then I rewrite this over here. So, all right, my next step to solve this is to move these two guys over here to make it equal to 0. Because whenever you have an x squared, you are looking to equal it to 0 to solve it. So here we go. Let's minus the 2x over and minus the 29 over. So the 2x would go to that, and the 29 would go here. Those are gone. I now have 0 equals x squared. When I combine these, I get negative 8x. When I combine these, I get negative 20. So I get negative 8x and minus 20. Yay. Takes a little bit of work. Now, can you see a factoring, hopefully? And very likely, this problem on the test will be factorable, not quadratic formula, because those get annoying for checking. So to factor this, which number is on top? Negative 20 is on top, negative 8 on bottom. So that would be a negative 10 and 2. So we have 0 equals x minus 10, x plus 2. Now remember, when you solve this, those are the factors. So what are my solutions or my zeros? It's the opposite. So what you're saying is what minus 10 gives you 0, what plus 2 gives you 0. So to get my zeros, it would be 10 and negative 2. Now these are your answers, but we have to check them. So let's plug in 10. Let's kind of squeeze it over here. I have 3 plus the square root of 2 times 10 plus 29 equaling x, which is 10. So if you do the work there, let's see what happens. We have 3 plus, isn't that going to be 20 plus 49? Sorry. 20 plus 29, is that 49? Now, won't that be 3 plus 7? Does that equal 10? Okay, we're good. So that one checks okay. Let's check negative 2. 3 plus the square root of 2 times negative 2 plus 29 equaling negative 2. All right, so that'd be 3 plus, what's negative 4 plus 29? 25. Can you tell right now that it's not possible? Isn't that 3 plus 5? Is that going to give you a negative 2? No, because this is going to be 3 plus 5 does not equal negative 2. So that means that's my only answer. That one's extraneous. Okay? Negative 2 would be extraneous, so x is 10 is my only answer. Make sure you check. Especially when you have two answers, checking is important because when you have two answers like this, a lot of times one of them has an issue. Not always. To solve this last square root problem, we want to get the square roots isolated. Since you have two square roots here, can we move one of them over? Yes. So I'm going to move the one that has a negative over to the right side. So I'm going to add this square root over to here. That's gone. I now have the square root of 3x minus 1 equaling the square root of 7x plus 5. So now that I have square roots on both sides, they're both kind of isolated individually. If I square both sides, do you notice the square roots vanish? And we actually have a fairly easy problem once I square both sides. Square roots disappear. And now we're back to basic algebra problem. Next step to solve is to solve a basic problem. Let's get x to one side. It doesn't really matter what side. I'm going to go this way. Minus the 7x over. And I'm going to do two steps at once. Sorry, you can do double steps. I'm doing it all at once. But it's okay. I got negative 4x equaling 6 here. All right. Then, from there, I divide by negative 4. So x equals negative 3 over 2. All right. But let's check that. It's like, darn it, fractions. Yucky. But we can check it. So to check my answer, I'm going to stick this back into my original. When I put 3 over 2 here and 3 over 2 here and subtract the two square roots, I should get 0. Let's see if it works out. Yummy fractions. So we got 3 over 2 minus 1 minus the square root of 7 times 3 over 2 plus 5. Does that equal 0? That is our question. Now, here we go. 3 times 3 over 2. We forgot. That's not 3 over 2. That's negative 3 over 2. So let's put those negatives there. So once we multiply it, we have the square root of 3 times negative 3 over 2. Isn't that negative 9 over 2 minus 1? Minus the square root of negative 21 over 2 plus 5 equaling 0. And now you're freaking out a little bit. Going, yuck. But can we stop? Yeah. Why can't we stop here and just say it's extraneous? There's no way that can be 0. Yeah, isn't that going to be imaginary right here? Aren't negatives minus some more negatives and negative? And isn't this 21 over 2, isn't that like 10.5? So aren't these both going to be negatives? And what do we say about imaginaries? We are dealing with real numbers here. So what do we know then? Guess what? Bad boy is no good. So there are no solutions. Because what was a solution created a negative in the square root, which would have been imaginary in your check. So yay, no solutions. Did all that to find the answer and it doesn't work. You went to the store, you bought something, and it didn't work, and there's no more left.